So for the folks that are on the call, welcome to the wasmCloud 0.50 release event. We're going to give it another minute or so to let folks continue to get connected here, and then we'll go ahead and get started. In the meantime, over on the right, you should be able to use both polls and emojis to interact with the content in real time. Sorry, not polls, but the chat. So if you have questions as we move throughout this, just try to surface your questions over on the side, and we'll go ahead and take time to answer. Afterwards, everybody that signed up and registered will receive a link to order some wasmCloud swag. You can refresh your wardrobe, get some new t-shirts and everything. And of course, I grabbed the green shirt on the top pile thinking it was wasmCloud, and it was not my wasmCloud t-shirt. So I'll be ordering swag too. Just give everybody another minute, then we'll get started.
Alrighty, we've done the important test. Emojis do work.
All right, it's a party. We just need somebody to go on mute and try to talk, and then I think we'll be all the way there. All right, let's go ahead and get this started. So we are super excited today to do the wasmCloud 0.50 release event. Next slide, please, Brooks. If you haven't been following along, this is our biggest release yet, and it's based on some critical feedback on how do we take wasmCloud to the absolute next level. And what we're releasing today includes this new hybrid Elixir Rust foundation on the back end, which really means that while the user experience is still very high level and friendly, it gives you more scale, more distributability, and more actors. Steve has really led a huge revamping of our developer experience in partnership with Brooks, who is going to demo the new Washboard, which is our web-based administrative control panel that you can use for driving your wasmCloud instances. There are new command line generators, and we've actually adopted AWS Smithy for modeling out your APIs. And then I'm not sure that we'll get to the demo today, but we have a new wasmCloud JS runtime that lets you start treating every browser tab as an additional wasmCloud process and host. One of the things from the community meetings that we have gotten a lot of positive feedback on, you can find those on YouTube now. Thank you, Jordan, for all your hard work in keeping that up to date. Totally lost my train of thought there. Is that we usually start with a demo. So when we planned today's concept, we thought we would start with a demo. So I'm going to go ahead and hand off to Brooks, and he's going to basically take us into our story. Brooks, over to you.
Yeah. Okay, cool. I just want to make sure you're muted, Liam. Well, hey, everyone. Thank you so much for being here. Really honored to be able to do this demonstration for you. I'm Brooks Townsend, and I'm on the wasmCloud core team. So today I'm going to be talking about the development process of an application with wasmCloud. I'm going to be showing off some of the developer experience features that they're dramatically simpler, and detailing some features like how we can easily scale out actors across seamlessly connected infrastructure, and how you get those kind of things for free with wasmCloud. You get to see just how we abstract away boilerplate code and allow you to focus solely on your business logic. To demonstrate this, to start, we're going to show you our demo app, which is a pet clinic application. Let me go ahead and share my screen again. All right, so this pet clinic UI here is designed to be run by a vet practice. It's a web application with a backend API that support things like displaying a list of vets, managing some different types of pets, adding owners and their own pets, and managing the successive visits that they have. And to show this off, I've clicked around a little bit in the UI to show you some of the tabs. I like to go ahead and add myself as an owner. So as said, I'm Brooks Townsend. I will avoid putting my email on this vet practice because I don't know if they're going to send me, the weekly spam for this vet. And I'll put in some other very real information about, personal identifying information about myself. Now, once I add myself as an owner, I'll go ahead and add my dog Archie here. He was born in May, so scroll back a little bit. And I'll add him as a dog. That's what he is. Now, just to show off the full functionality of the web app, I'll go ahead and put in a couple of things that he's gone under the vet for. He had his monthly heartworm medication, that was due at the start of the month. And he went to this specific vet to go get that done. And he also had to get his rabies vaccine relatively recently. That was just a little bit earlier. So this is essentially the pet clinic application. You can see that this data is persisted. If we take a look at the visits, I have myself here, or the different visits that Archie has gone in for. If I want to go back and edit myself, I can change my phone number if I'd like to update that. And again, we can view information about vets and pet types. Now, I'd like to talk a little bit about the composition of this application. What kind of services and requirements do we need for a pet clinic application? So from a business standpoint, we need to do the things that I've shown you: track vets, track owners and their pets, the reason for their visits, and persist that. Who cares what type of database that's all in, or how the inner workings of our HTTP interaction between the application and our backend API. The whole business need revolves around the pet clinic itself. So I'd like to go ahead and get into a little bit of an architecture diagram, starting with the application that we were inspired by. Let's see. Okay. So this is the architecture of the Java Spring Boot Pet Clinic. This is the microservices demonstration that we are inspired by to make this application. And you can see multiple different components in this application, namely the things in blue are detailing the specific services. But mostly you can see a complex tangling of our business need, which is in blue, and the specific vendor components, what we like to call non-functional requirements, built right into the actual design of the application. Now, I'd like to go ahead and show you, I see some things are popping up in the chat. So, as I'm going along, we have our other team members here that would be happy to answer those questions. So if you think of anything, just go ahead and drop it there. Now, from here, I'd like to move on to the architecture diagram for what this application looks like with wasmCloud. The business logic is expressed in the blue components over on the left, which are signed WebAssembly modules that we call actors. And the non-functional requirements are over a little more on the right in red, things like the HTTP server provider, SQL database provider. These non-functional requirements, or the way that they're being expressed here, are not concrete services, the way that you see built into many architecture diagrams. They're simply abstractions. And when you code your business logic against these types of abstractions, the actual backend API, the service that handles adding new customers or owners, has no knowledge of the backend database. The fact that it's Postgres in our application is completely unknown to our business logic because it doesn't matter to our business logic. Doing it this way from the perspective of our actors, we can swap out the non-functional requirements at any moment. Now, to give you a better idea of what role these actors and capabilities play in the grand scheme of computing, this is a diagram that kind of illustrates the evolution of abstraction over time. Starting with just a computer, everything's very tightly coupled together. Moving on to the cloud and in VMs, where we abstract away the hypervisor. And then with Docker, where we abstract away things like a specific operating system. And then with WebAssembly, where we can even pull the host libraries out of that equation so that you can have a truly platform agnostic language or framework. Now, we build on top of where WebAssembly is by taking this a step further and separating the capabilities, or as I've been calling them, the non-functional requirements, out of the application itself. And what this does is that ends up leaving you with just your pure logic to write. The non-functional things like what specific database it is or spinning up an HTTP server, those are things that are completely pluggable. We like to use like a Lego model. You have your actors with plugs, and you can always plug in a different capability at runtime if the need arises. But the code that you have to write with wasmCloud is completely focused around your business application. Now, in order to understand how these actors are composed and how we're able to create this abstraction, you first have to understand WebAssembly. So to keep it short, WebAssembly has a couple of very key features that we're able to take advantage of. It's secure. WebAssembly cannot access anything outside of its own linear memory without being expressly allowed to. It offers near native performance out of the box, allowing us to avoid the overhead of a container. It's portable, lets us run anywhere from the cloud to the edge, even in a web browser tab. It's scalable. Normally, WebAssembly modules go anywhere from 10 to 500 kilobytes, super dense, easily scalable. And last but not least, it's very customizable. Not only do you get your own choice of language, when you're writing WebAssembly, you can do it from anything from Rust to C to even AssemblyScript. You also, at runtime, get to choose your form of execution. This can be just-in-time interpreted or ahead of time compiled, which is very important for constrained devices to be able to make this choice without changing your code. So WebAssembly certainly gives us some power here, but there are still gaps. The ecosystem is small, the tooling is limited, and without a fully featured runtime, it's difficult to really do much more than add a couple of numbers together using WebAssembly. And this is where wasmCloud comes in. So now that you understand what we're getting from WebAssembly, you can look at the layers that wasmCloud adds to build on top of the technology. So as mentioned at the base, we are a WebAssembly host runtime. We run signed actors, which are WebAssembly modules, and that is our business logic. On top of the WebAssembly runtime is the wasmCloud application runtime. We provide the abstractions of the non-functional requirements, things like abstractions over talking to a database or abstractly performing as an HTTP server. And we do this to remove boilerplate code and take advantage of the WebAssembly deny by default sandbox to securely give access to those capabilities. Speaking of capabilities, at runtime, as mentioned, you get to pick what your actual concrete implementation of a capability is. We design our entire application around an abstraction so that when you actually end up running your application, you can choose your specific database, your specific vendor at that time. Everything is driven by contract-driven design, as we like to call it. Now, of course, who's using these non-functional requirements, where our core business logic is in the actors. As mentioned, they're small. You can easily compose them to make a very dense application. And I like to call these reactive, scalable little nuggets of distributed compute. And then to bring it all together, wasmCloud hosts are completely seamlessly connected through our lattice. We leverage NATs to create a flattened topology of resources, which is seamlessly connected no matter where the actual infrastructure is for your application. So now I'd like to, I've introduced wasmCloud and WebAssembly and some of the things that we're gaining from that. I'd like to take you to our new and improved wasmCloud dashboard. So this dashboard is This dashboard supports a full lattice view of your application components all in one page. You can see right out of our architecture diagram where we're running our specific application components, our business logic over here with actors, with our API, the customers, visits, and bets services. And then on the right, we have our concrete capability providers. This is our actual HTTP server, our actual SQL database, Postgres provider, and these are things that we choose at runtime. As mentioned, we do contract-driven design. The way that we're actually able to get our actors and providers to communicate and what kind of brings this all together is the link definitions. So we link our actors and our providers together when we actually launch the application at runtime. And this allows them to communicate over a specific contract, whether it's an abstract SQL database, abstract HTTP server. And this is all done without any infrastructure or physical location in mind. So all of these things for now are just running on my local machine, which is perfect for doing things like development, immediately making changes, and testing those changes immediately. So speaking of the developer experience, I'd like to show you what it's actually like to take a look at some of this code and write business logic with wasmCloud. So I will have to do a little shuffle here. Alrighty. So just to take a step back and remind everyone where we are, our business requirement is to create a pet clinic application. So the business logic should, and the code that we want to write, should revolve around handling specific things like handling an endpoint to get all of the different bets, handling an endpoint to create an owner. And we should expressly avoid, creating a database connection or anything that doesn't revolve around just the business logic. So here we're going to take a look at our API actor. This is the actor that's going to be receiving the HTTP requests from the web application. And the way that we write this API actor with wasmCloud is by implementing, I just got a message that the code is messed up. Are you all able to see the VS Code?
Yeah, so I can see the VS Code, Brooks.
Okay. All right. Well, I guess it's just Kevin's machine acting up on us, of course. Anyways, so we're looking at this API actor. The way that we do this contract-driven design with wasmCloud is by implementing a trait. And this is written in Rust. A trait is very similar to an interface if you don't have Rust experience. All this trait has is a single method called handle request. And this is truly the most abstract representation of an HTTP server. This handler receives an HTTP request and returns an HTTP response. Now, for us with our actor, when we start writing our code, you can see we can get right into logging the things that we're receiving and parsing out what types of HTTP requests we have. So you can take a look at this match here. We're handling get endpoint for pet types. We'll handle a post request for creating an owner, all those things. And if you notice, if I scroll around in this code a little bit, and I'll go take a look at one of the endpoints all the way through, what's missing here is, initializing the logging experience, initializing an HTTP server. That's all not present here. This is all you have to do to start writing an HTTP server. So I'd like to go a little bit deeper and show you, you saw me create myself as an owner. Let's take a look at that flow. So if we have a post request to the owner's endpoint, we send that owner body over to this function. What we do here is we create a sender. And what that is a way that we can directly communicate with another actor in our application. In this case, the actor that's responsible for creating the owner is going to be the customer's actor. This is kind of a standard microservice separation of responsibility pattern. So we send this owner over to our customer's actor and wait for the response and then return an HTTP response with whatever that is. Taking a look at the customer's actor, where that actually happens, you'll see something very similar. We're implementing a customer's trait for this customer's actor. This customer's trait is, again, another contract. It's an abstract interface that the API and the customer's actor agree to communicate on. This create owner function does something very similar. We create a SQL database sender, which is how we can make invocations on an abstract representation of a SQL database. And it's in another module here, but if I go to that create owner function, what we do is just a little bit of deserialization, but then all of the business logic, the interaction with the SQL database is right here. We use a database client to execute a query, inserting a new owner into the table. Fairly simple. And if we kind of trace this back up, we return a result saying that that's okay. And then we reply to the API actor, allowing it to finally give us our successful created owner. Now, again, I just want to be clear here, and I want to reiterate that if we scroll around in this code, you can look all day for where the database initialization logic is. We can scroll around the Clinic API and look for where we're spinning up an HTTP server and telling what host name and what port and everything that we want to listen on, but you won't be able to find it. All of that is absent from our business logic, as it should be. We got to get right down into writing the actual logic that puts forward this pet clinic application. So to give you a little bit more of a feel of what the development process looks like with this, let's go ahead and take down one of these endpoints for maintenance. Now, one that should be fairly fine to show off. I know that we had an endpoint for getting all of the vets. And if we take a look at so scroll down on our Clinic API, where is it? There we go. We have our endpoint here for retrieving all the vets. Does something similar. We send a request to or we directly invoke the vets actor and ask for all the vets. Now, if we edit this, what we can do is just change our response to say something like bound for maintenance and return a 503 instead of a 200. Now, I'm going to scroll up with my terminal here. You all should be able to see the whole thing. I don't think there's anything like Zoom where you blocked on it. So if I go to the Clinic API actor and run make, first and foremost, this is going to run a cargo build, which is how you build build anything in Rust. You're going to see some warnings, but that's just because I'm not using some of the variables that I had from the vets actor anymore. And then lastly, this make, first step is building the actual WebAssembly module. Second step is cryptographically signing it. Now this is using our wash tool, which is the wasmCloud shell, to cryptographically sign this WebAssembly module and embed a JWT inside of it. This contains a couple of pieces of information, notably things like who's actually signing it, my specific signing key, the name of it, what specific version, but most notably are the capability claims. As mentioned before, WebAssembly modules can't access anything outside of its own linear memory. Without anything else, there's no way that this WebAssembly module could receive an HTTP request or send out a log to our host runtime. But since we sign this WebAssembly module with the capability for wasmCloud HTTP server and our built-in distributed logging framework, that actually we know from the wasmCloud perspective to allow this actor to access those resources. We can also use the inspect command to take a look at the Clinic API actor. This can be done on any wasmCloud actor, whether it's on your local machine or even in a remote OCI registry. So at a bird's eye view, you can see exactly what this actor's capability is. If you look under the capabilities section, somebody says, oh, you should just go ahead and run this actor on your wasmCloud host and you see the wasmCloud Bitcoin miner capability, then you know that something is up, because that API probably shouldn't be responsible or able to mine Bitcoin for you, just for an example. All right, well, now we've made that change. We've built and signed our WebAssembly module. Let's go ahead and update this in our application. So again, do a little switcheroo. If we go back to the dashboard here, this is exactly what we left out at. But what we can go ahead and do, just to show off real quick, we're actually able to hit our Pet Clinic API directly on localhost. So if we do localhost, I believe it's 8080, and hit the vets endpoint, you can see all those vets that we saw on the Pet Clinic page before. So I'll zoom in a little bit so that you can actually read the things, but these are our pet things. Oh no, too far. Okay. Anyways, you saw that those are actual vets. What we can go ahead and do is take our Pet Clinic API. We can scale it down to 0 replicas to remove it. And then we can directly start an actor from a file. And as we're doing this, we can add in, multiple different replicas if we want to. Sorry, that must be the wrong actor. Okay, anyways, we can start the Clinic API actor just as we made it. You may not have been able to see it from the thing, but it just brought up a little file upload section for me. So we start our Clinic API actor, and immediately we can go hit our API. We see that that endpoint is down for maintenance. So in order to do this update from our old Pet Clinic actor to the new one that we just uploaded from our local file, it doesn't require any configuration changes, nothing like that. Requests are immediately forwarded to the new API. All right, so I've shown you the kind of some background on some wasmCloud features, shown you some of the developer experience around developing actors. Now, I mentioned that we're currently running this application all on my local machine. All of the providers, the non-functional requirements, and the actors are all right here on the dashboard. And if you take a look, they're all running on my local host. Now, I've got some of my colleagues here in the live storm. We have Kevin and Taylor, our CTO and one of our lead developers, on standby. And something I didn't mention before is that this whole time when I've been running this wasmCloud host, it's been using a NATS as a leaf node. This allows me to easily connect to NATS global service in GS, and anyone with the same connection and same credentials can automatically connect to each other. So they're also running as leaf nodes, and if they are ready, if they could go ahead and launch the wasmCloud host on their machine, we'll slowly see this pop up in the dashboard as they are able to get it up and running on their side. See, you can already check out our little host selector here, right? We've got two. If we take a look at this other host that we have here, we've got it running on an ARM device, which is a Raspberry Pi, all seamlessly connected. We'll wait a minute for the other ones to come in. You can kind of see them automatically popping up and live reloading here. If I take a look at this one, we have an x86 Linux wasmCloud host. The second one is also an x86 Linux host. And then there should be one more coming in here in just a moment. Aha, there it is. I think it's this one. Hard to read. There we go. Our x86 Windows machine, courtesy of Taylor. All right, so without any live reloading, without any discovery, it's not like in the background, you could see my hands as I was talking. I wasn't sneakily connecting by, directly inputting their port forwarded port on their machine. This is all done seamlessly through NATS. And what I'd love to show you now is let's go ahead and take our application and turn the knob from local machine to fully distributed. So on this Linux machine, let's go ahead and start out a couple instances of the customer actor. So customers 0.1.0, and we'll start up, let's say, 4 replicas. Let's go ahead and go on to the Windows host and start up a couple instances of the bets actor. Not 31, but we could. And where is, let's see, we started on Linux. Let's go ahead and launch another one on the Raspberry Pi. And that is going to be the visits actor. We'll start, I don't know, we'll do 5 replicas on there. All right, so if we go to the all host view, we can see all of our different services a little more blown up now, because we can see we have our pet clinic API, we have a couple different replicas across different hosts. And what I really like to show to just drive the point home is, let's go ahead and just remove all of the original actors that I had. This is on my Mac OS machine, drop it down to only the pet clinic API on my side. And so all of these different actors are running across all those different wasmCloud hosts. If we head to Pet Shop Clinic again, you can see me. You can see my pet Archie coming right up. There's no downtime. Automatically, requests are being forwarded to the actors across this network. And there's no configuration changes that I had to do. So just to really drive the point home here, our application at the top level view logically looks the same. This is how it's supposed to look from our business standpoint. It has the same components, but instead of all running on my machine, we seamlessly turn the knob to microservice distributed there. And our pet clinic actors are running on 4 different hosts in 2 different time zones across the US, across 3 different operating systems, and 2 different architectures. In order to actually get this to work, we had no code changes, no changes to configuration, and no downtime. Just in case it was lost, the same exact actors are running on all of these different platforms thanks to WebAssembly. So to wrap us up here, we've demonstrated an application of many different microservices with drastically reduced boilerplate code. Because we were able to write it with wasmCloud, we could eliminate the boilerplate by separating our business logic from those non-functional requirements. We could run the exact same actors across all of these different operating systems and architectures, and could seamlessly connect to all of these different hosts to turn this application from something I was just running on my machine to all across the world. And these are some of the many game-changing elements that we're trying to bring to software development with wasmCloud, along with our overall mission just to bring joy to distributed applications. So now that's what I have for the demonstration. We have plenty of time for some Q&A for us to all hang out. If anybody's interested in seeing anything in particular, if you want to see more about the actor development process, if you want to see some more of our Smithy interfaces, or if you want to talk about anything about our new host runtime, then now's the time.
Okay, and I'd like to invite the rest of the core team here that's present. We still have a couple of folks that aren't on the call to go ahead and come on video, please, and unmute so you can participate in the discussion. Hey, nice shirt, Kevin.
Yeah, I picked the right one.
I changed.
Did that require a phone booth, or?
Unlike wasmCloud, I actually had to change, the underlying.
Yeah, see, what you need is you don't have zero downtime clothing change.
I don't have zero downtime clothing change. I had to walk away from my desk.
Yeah, we need hot swappable T-shirts next. That'll be a new feature.
It's great. Well, I don't see too many questions coming in, but you're welcome to ask questions about anything at all. Let's see, Jenna, would it be interesting to see side by side what it takes to deploy a distributed app in different environments with wasmCloud versus without it? There's actually another great opportunity for that at the WASM Day program, which is next week. I'll drop a link in the chat here in just a moment for those that haven't signed up yet. Stuart Harris from Red Badger is going to be doing a great demonstration of using wasmCloud to do live failovers on between two different clouds in a Kubernetes environment. So I think that there are some additional demos along the way there. Travis asked, what are the steps to add new capability providers? Kevin, do you want to take that, or do you want to let Steve do that one?
I can take it. Steve might want to provide some detail on the way we do modeling and code generation, but the short answer for creating a new capability provider is if you're creating a new provider for an existing contract, then all you need to do is type wash new provider at your terminal prompts, and we'll give you a new scaffolding for it. And you just essentially fill in the blanks, and you're off and running. If you want to create a new interface, then Steve may have some good commentary on this.
Sure. I wasn't sure from your question, Travis, did you mean adding an existing provider to the application? So if what you wanted to do was add another provider, say a key value store or something that already exists, then you need to sign your actor with that capability, as Brooks showed, by adding a claim to the WASM, and then you deploy it, and then on your dashboard you also need to deploy the provider, and they get hooked up. And the fact that they get hooked up later at runtime is really key, because whoever is running that dashboard can choose which implementation of the contract you're going to want to use.
Travis, did that answer the question as far as the two different modes? If there's an existing contract that already exists, or if you're creating a new one from scratch for a capability that doesn't exist, say like a machine attached GPU or something. Okay, great. Thank you. Yes, that's a great link. Thank you for sharing that, Travis. So what other questions do folks have about wasmCloud, or where the project's going for the core team?
I just wanted to, everybody please chime in with questions, but I really just wanted to bring Jordan's point from the chat out. His question was, let me get this straight. If somebody just opened a wasmCloud JavaScript host up in a browser tab, it would have come up alongside the Linux and the Windows and the Raspberry Pi hosts, and that's exactly right. If you open up a wasmCloud host, in this example, you're connected to the same as a Leaf node, the same way that we are. It pops right up in the list, and we can schedule the same actors in a web browser.
Dwayne asks, what was the driving factor for moving the runtime to Elixir, Kevin?
So we have a really long formal answer for that. If you look at the architectural decision record that we have in our GitHub, you'll see kind of a lengthy explanation for why we ended up with Elixir. In addition to that, we also have two different ElixirConf presentations where I go into about 40 minutes worth of detail on that. But the short answer is, as we were trying to add more features to the Rust runtime, the whole purpose of wasmCloud is to remove boilerplate from the development experience. And what we were noticing is that with our Rust runtime, we were spending 90% of our time adding async and multi-threading and concurrency boilerplate, and not actually adding new features. And so one of the things that we get with Elixir, and specifically Erlang and OTP underneath it, is all of the decades worth of experience in building massive scale concurrent systems we get for free. And now we get to essentially declare our concurrency model and then forget about it and then work on actual features. So, focus on our business logic.
Dwayne, I'd like to add that, as a team, we sort of have a tenet around aligning to best practices or best of breed solutions. So when you look at the way that wasmCloud has emerged as a project, we would move into an area quickly with a POC and get some feedback. And then we would start the search for the rest of the abilities that we would want in software around, scalability, performance, and so forth there. So this is where the project has really ended up aligned with 3 great communities that it didn't make sense to rebuild. I would put Nats in that category. If we needed a high-speed, transparent networking mesh, it was perfect. I would put Elixir in that category, and I would also put the new Smithy alignment in that category as well, where we needed the ability to bring some mature, tested solutions into our ecosystem for scaling and modeling APIs at big scale, because that's what our proposed users were bringing to us when we would talk to them about their problems and the scale of their operations. Was we just needed to think globally. And what that does is that also allows us as a team to really be laser focused on adding value around the experience of using all the tools together, to spend time on building out demos and integrating with these particular components. Did that answer your question, Dwayne? Super. Thank you so much. That was a great question. What other questions do we have? Anyone else? Stuart Harris, I'm just going to read it. It may be a question. It may be a question comment. Let's see here. I can't quite get over how significant this is. It's history in the making. wasmCloud elevates us above any cloud or edge, giving us homogeneous surface on which to build our applications for the first time ever. So exciting. Stuart, I could not share your enthusiasm anymore.
I should point out that we didn't even have to pay him to say that.
It's $5. A word.
Oh, okay.
Yeah. That's why it's like reads a little bit like a teletype, at the end there, like a Morse code.
Yeah, each one of those extra periods was more money in the bank.
Every time. No, Stuart, look, you and your team have showed up in the community. I mean, it blew me away when I started to see your blog post. I was like, who in the hell is this guy? We never talked to him in our lives. That's what the experience of wasmCloud has really been in the last, a few months, and this year especially, is, we just continue to pick up momentum as a team. Joining CNCF, I think, is an accelerant for that. And certainly now, as Cosmonic has started to fund additional resources to accelerate the development effort full time, I think that we're really on the way to wasmCloud becoming self-aware in 2023. Maybe not that far. Great. What other questions do we have here, or comments or anything else? I think I spotted Enki. Go ahead. Sorry, go ahead.
That he spotted NKeys. That is correct. One of the things that we didn't really go into too much detail on is the decentralized nature of wasmCloud security. One of the things that you can do with Docker in production environments is you can define rules about what images can run, but you have to consult a central authority to figure out what those rules are. And the problem with that in the cloud is sometimes that central authority is offline, sometimes the network is down, or even just sometimes the latency is too long. And so with our wasmCloud modules, we need to be able to verify what a module can do without ever having to consult a central authority. And one of the many technologies that lets us do that is embedded JSON web tokens, and we sign those using ED 25519 keys. And one of the things we took inspiration from Nats on is they created their own user-friendly encoding for those keys to make it so that those keys are double clickable and URL friendly. And that's come in super handy all throughout the development of wasmCloud. Yeah, exactly, Todd. It's not really distributed computing if you have to consult a central server. It's more like, a super wide client server, and that's not what we're going for.
I am going to pull the language, Justin. Everybody that registered will receive an invite link to order their swag, and the click-through gate will be a short little survey. So if folks don't mind humoring me when you order your T-shirts, there are T-shirts for both men and women available. So feel free to order, whatever you need from a size. If there's any concerns, just send me a DM on Twitter or somewhere else, and we can get that taken care of. Real quick, I do want to highlight a couple of upcoming events. If we don't have any more questions. Steve, did you want to say something? Okay, great. Let me just share my screen here real fast. And I'm sharing into infinity. That's hilarious. That's hilarious. Okay, maybe I won't share my screen. I'll just drop some links in. This Saturday, we've got the wasmCloud team is super busy. This Saturday,
share a window. Share a window, not a screen.
There we go. This Saturday, we have the Cloud Native Rejects, where our own Taylor Thomas will be sharing him. KubeCon may have rejected him, but we sure didn't. Then on Tuesday, the 12th, we have Cloud Native WASM Day, which I co-chair with Ralph from Microsoft, and we've got a whole day of WebAssembly content planned. So that'll be available on live stream. And if you're in Los Angeles, both Taylor and I will be in LA next week for Reject, the conference. And we will have a booth at KubeCon this year. You can find us under the Cosmonic booth. And the final link is at KubeCon then. Not only do we have the booth, but on Wednesday, October the 13th, you can also catch wasmCloud again in the main session for Cloud Native web services. So I really look...
Sorry,
go ahead.
One other thing, I don't have the link handy right now, but if you are attending ElixirConf US, I think it's a Thursday, the 14th, my virtual session goes into detail on rewriting our Rust runtime into a Rust Elixir hybrid.
Yes, thank you so much, Kevin. And again, then on Thursday, so if you have not had enough wasmCloud time, you can catch us again on Saturday, on Tuesday, on Wednesday, and Thursday. It truly is the week of WASM, week of wasmCloud. And thank you, everyone, so much for coming out. You'll get an email from us afterwards with a short little survey and a link to order lots of free wasmCloud swag that gets shipped right to your house or home or wherever you happen to reside. Thank you so much for coming. We're going to go ahead and end the event. This immediately becomes a live stream. So if you want to share this event, you can share a link right out. It should be public to the world. We'll also pull down these videos and post them on our YouTube channel, which is available at youtube.com/wasmCloud. And as always, follow us on Twitter at Twitter/wasmCloud as well. Anything else? Closing? Brooks, amazing job, buddy. You absolutely killed it, man. You're amazing. Yeah. All right. Thank you, everybody. Have a great day. Bye.